Yes. Hello, everyone. And now I realize I was muted. Okay. Okay. So, yes. Thank you, everyone. And now I realize I was muted. Okay. Okay. So, thank you. That was a big chaos. Okay. So, live issues. Anyway, so welcome again. Probably the third time you hear me saying this. Welcome to the second panel. So we are in the final day of the Open Nebula conference, as you know. This day is devoted to research and innovation in cloud and edge computing. So we decided to have a full day focused mostly on the COGNIT project, which, as you know, is a Horizon Europe project that Open Nebula coordinates. There is also a fantastic consortium. Some of the members you will meet them in a second. This project has been running since 2023 and will be running for 3 years till the end of next year. So in this second panel, we want to focus more on the perspective of the use cases and the applications that are using the Cloud Edge Continuum, the cognitive cloud that we are building. So we want to know how a number of specific sectors in Europe are approaching this movement from the cloud, from the centralized cloud to the edge, and how they are starting to use these technologies in a specific domains. So today I'm very lucky because we have a very interesting set of speakers and panelists. So we have Antonio from Atisa, Francesco from Nature 4.0, Kaja from Phoenix Systems, Malik from CETIC, and finally Thorsten from SUSE. So we are going to be discussing with them, as I said, the specific application of the cloud edge computing and how it's been adopted in different sectors. Okay. As I mentioned, the COGNIT Project, supported by the European Union. And yeah, let's go ahead and let's bring everyone on the stage, and we can start the discussion. I'm not muting now, right? I've been speaking. You've been able to hear me, right? Perfect. So welcome everyone. Now we can see you all. We can probably hear you all as well. So my first question is going to be very quick. So I would like to have for people that are not familiar with the COGNIT project, a quick round of introductions to know your companies and what you guys do and what are you bringing to the project in this case. So let's start with Antonio, for instance.
Thank you, Alberto. Hello, thank you for the invitation, and hello everyone. Yes, just to really present Atisa. Atisa is a 40 years old company. We have many experience in not in the open source scenario, but mainly in executing end-to-end projects in traffic management, mobility, smart city, and also renewable energy. We are an integrator company, mostly focused on engineering, installation, maintenance works. Recently, we have successfully developed some solutions that we move the deployment from the traditional on-premises infrastructure what we used to work with to hybrid cloud edge scenario. And this is the reason that we are here in the as a panelist. We continuously keep incorporating cutting edge technologies such as V2X, artificial intelligence, and we try to keep more in the forefront of the innovation related to cloud and edge deployments. Yeah. Thank you.
Right. Thank you, Antonio. Francesco, go ahead.
Hi everyone, thank you for the invitation. Nature4 is a company located in Italy, and we are a small company about IoT for environmental monitoring and management. Our main device is the Tree Talker, a device for tree health monitoring with parameters such as subflow, light through the canopy, and growth sensor. But we are very active in research and development. Some of our devices are, for example, gas concentration monitoring or turtle monitoring with GPS and depth of diving, or others such as animal health and well-being with heart rate, accelerometer, GPS, but also subcutaneous temperature sensor. For the project, we are experimenting with a device called that for wildfire early detection, the Fire, and that collect the images, can send it, and has the name imply able to recognize fires and help the civil servants to fight it properly.
Okay, great.
Thank you.
Kajan, go ahead.
Hello, everybody. Thank you, Alberto, for inviting me. It's a pleasure to be here. So I'm representing Phoenix Systems. We are developing Phoenix RTS, which is the open source operating system dedicated for edge IoT devices. We've been on the market for 12 years now, and we are mainly now operating in the smart grid market, as there's like over 1 million devices that is using our operating system in energy meter, gas meters, data concentrator units. We are also active in the aviation market, as we are doing also the autopilot based on our operating system that is used to pilot unmanned aerial vehicles. And within the COGNIT project, we are focusing on the energy use case, where we are developing the meter that is the new generation with new ideas that could be checked and implemented on the meter. So we are here to test the whole COGNIT idea, what it can give to end devices, to IoT edge devices, how we can increase the abilities of those devices. And in our specific use case, we want to do it to balance the production and consumption of each household. So hopefully we will achieve this goal next year, and we'll have something to be proud of. Thank you.
Great, I'm sure we will. Malik, go ahead.
Yeah, hello everyone. Thank you for the invitation. I represent CETIC, a Belgian research center specialized in information and communication technologies. We work on a variety of innovative projects, including cloud computing, IoT, cybersecurity, and artificial intelligence. Our mission is to help businesses transform technological advancement into practical and marketable solutions. And as a part of the project, we are responsible for the use case 4, which concerns cybersecurity. And in our use case, is to demonstrate the usefulness of a project like COGNIT in addressing cybersecurity challenge. We've imagined a scenario involving a fleet of autonomous vehicles. And we are focused on the threat.
Actually, one of the most interesting scenarios that one can come across is when devices are moving, but we'll talk about that a bit later on. Then last but not least, Thorsten, go ahead.
Hello, and also thank you for inviting us to this panel. So my name is Thorsten Hamann, and I'm working for SUSE in the public affairs area. SUSE is, I guess many of you will know SUSE for the Linux systems, operating systems. But in general, SUSE is also looking into other areas of open source infrastructure. So for instance, in managing container-based applications, also securing container-based applications. But in general, across all these container and Linux items, we are looking also very much into the security aspects, which also brings us to the table in this consortium when talking about, okay, if we place something in the edge area, I mean that's in an area where you don't have the perimeter of a data center, right? And so that means you have to look at how you are securing these kind of applications. And this is where we also play a role here. So not only on the operating system base, but also on the confidential computing area, where we are at the forefront when it's about how we implement and enable our operating system for that. So that's mainly why we are here, and it is also a lot of fun, of course.
Great, thank you all. My first question, I think, is for Thorsten. Are you actually wearing a corporate polo? Is that the green?
No, not really, not really. but I was going shopping with, yeah.
I was hoping I wasn't the only one. Okay, fair enough. Okay, let's move to the second question then. So when we're talking about this shift, right, that we're seeing in the market, I mean, this transition from the centralized cloud to the edge, we put a lot of emphasis on sometimes on the geopolitical aspects of all that, and how that might bring or will bring, is expected to bring some benefits to the European market, open up this market to more providers and all that. But now that I have you all here, and you're all coming from many different sectors, many different, actually also many different countries. I mean, you in this call, and we are lucky in the consortium, we have this nice combination of member states as well. I mean, I see you guys are coming. We have your companies based in Spain, Italy, Poland, Germany, and CETIC in Belgium. So, but from your different perspectives, how do you see this shift from the centralized cloud to the edge when it comes to the needs of the actual edge applications on the IoT devices? How do you think if this is going to actually bring real benefits to these devices at the edge? So who wants to start? Maybe Kaja, you have some practical challenges that you guys have been looking at.
Yeah, we do. Well, the main obstacle that I personally see is the lack of dynamic changes that we could do with the centralized cloud computing. So we always have some bottlenecks that we have to overcome. It is very difficult to make solutions scalable. They reach certain level, and then it becomes really difficult. And well, those are the main problems that I think we could answer and have solution for with initiatives like in COGNIT Project.
Okay, great. What about you, Antonio? Because you guys also in the smart cities environment where you work, I mean, that's you very much deal with these large scale deployments of IoT devices. How do you see, what kind of limitations you've been facing, for instance?
Well, the first limitation regarding the centralized cloud computing is that we couldn't use it. So till some years ago, our customers, mainly city councils and kind of customers, they don't want to go to the cloud. All of them has to provision on-premises infrastructure, and we should deploy our solutions there. Just recently, in the last couple of years, they are more or less kind of open to use and to consume software as a service. But for us, it's like for us the IoT edge is like our normal scenarios where we used to operate, and we just recently integrate with the cloud. So we feel very comfortable in this area. What our challenge in there was that as an integrator, we have to integrate a lot of systems with different protocols, different process to connect them. Also integrating different networks from our customers that were designed different in every case. So our main challenges was to deploy solutions there for our developers. They have to learn for project to project every infrastructure. So this project for COGNIT for us would represent like to present a more transparent infrastructure to our developers, so they don't only have to care about the applications, right?
Okay. What about you, Francesco? How do you in the environmental domain? What kind of limitations you've been facing?
The integration already already nominated is important also because in the other you are obliged to have a single provider, for example, for your services. If you need to have your system along with another one, you need to find the ways to integrate it in a clever manner. And also, perhaps sometimes, if you have actuators, you want to have edge, but perhaps you don't want the edge to be your only solution. You would prefer the server, but if you do not have connection, in particular in remote areas, you are interested to have always an edge that can manage at least the main tasks. And we hope that COGNIT can help to manage all the possible resources. Some, for example, of our main resources in our base, some from providers, and also from the edge. So the possibility to be very flexible depending on the cases, because we have often perhaps a lack of connection or something like that.
Yeah, I was going to say that, right? I mean, when you have these large kind of deployments in a forest area, there are also, I mean, there are the limitations of the centralized cloud, but there are also all the physical limitations, right, in terms of connectivity. Okay, so Malik, what about you? Your experience with in the mobility use case?
For me, there is an issue about the latency, because IoT devices often require very rapid response that centralized cloud services cannot always provide. For example, imagine a health monitoring application where wearable sensor need to analyze vital signs in real time to prevent Earth attack or something like this, or another vital signs. So the delays in communication with the centralized cloud can be dangerous because an edge model would allow, for instance, local data processing. There is maybe another thing about the security, because the data security during transit to the cloud is also a major concern. In terms of security, connected medical device sends sensitive data to the cloud, which increase the risk of data interception and data leak. So local processing reduces the number of transfer and the security risk during the transport of the data.
Yeah, I think a number of sectors, European sectors, are very concerned about also this transit of data. What do you think, Torsten? I mean, you guys are very active, for instance, in the automotive sector, in other industrial sectors in Europe. Do you see also this some of your customers and users facing these kind of limitations of the cloud, the traditional cloud model, and moving towards the edge, or maybe an edge that, as Antonio mentioned, might be more familiar to this concept of owning your own infrastructure, I mean, closer to your devices?
Yeah, so what we see, if you look at edge computing, it's do your number crunching where the data is, where your data happens, right? But we all know, I mean, for me, for instance, the wildfire detection case is a very, very perfect example, right? Because it shows you have your constraints there, and as much as you would like to have the full, let's say, computation on the really the device, the edge device, it is not feasible from cost perspective, right? So I guess that's also especially why it was very interesting for us with the COGNIT project, because it tries to balance exactly this, right? Do what you really need at the core of your edge, and then go a little bit more closer to where you have the computing resources to do stuff that wouldn't be possible at small, tiny devices, right? And so from that perspective, the problem with centralized cloud computing is it lacks the flexibility on one hand, because it could not be as close as possible where you need it to be. And also on the other hand, typically also a scalability issue, right? Because if you look, for instance, again here at the wildfire detection case, it could happen that you very quickly have to run hundreds of instances to do your number crunching, and this also what Malik was talking about with regards to the latency, very close to where you are. So, and this is exactly what I think. It's the balance that this project gives, which makes it very interesting, and addresses exactly this kind of combination that you can see in centralized cloud computing.
I think you said one very, very important thing. You said, well, do the computing on the edge as much as you can, and then come to the place where you can do more computing. But with centralized, what should come? The device should come. It can't. Well, maybe except of those cars that actually move, right? But we need the completely reverse approach. We want the resources to come to us, to the devices, to be available to the devices, to the end devices, so we can do more on them using those resources. And we want those resources to be available in the exact time that we need it, because why should we have it when we are not using them? So this is the main problem with centralized, that you have to come there.
Yeah, it's another level of it's about the kind of almost about the density in between the device and the centralized cloud, right? It's like there is no depth between the right now from the application of the device to the centralized cloud. There's like an empty space in there. So yeah, but I guess this continuum involves that we have to create this and have this presence. It's much more complex, right? Because you have to spread and distribute all these resources, not just in terms of latency, but also in terms of the actual cover of territory with resources that can be used or not, depending on the specific requirements or the availability of other resources in the vicinity. So it's much more complex. But yeah, it's changing this. Yeah, it's where you put the emphasis. It's you come to us, or you or the device do as much as you can, and then when you cannot do anything else, or you need some specific capabilities, and you ask for this kind of proximity cloud, let's say, to offer that locally instead of going to a data center that might be 1,000 kilometers away. Yeah. Okay, so one of the things we've been discussing in the previous panel has been we've been looking at this, for instance, the use of artificial intelligence, as you know, is one of the key components of the COGNIT project. How artificial intelligence is expected to be used as part of the operations of this cloud edge. So to manage all this complexity of new providers, thousands of new nodes, locations, capabilities, changes in the infrastructure. How artificial intelligence is going to help to optimize that and to operate all that. But then we finished the discussion with approaching this topic of artificial intelligence from the other perspective, the opposite perspective, which is what kind of things are going to be required by an AI application from this cloud edge. So what do we need to incorporate into this cloud edge or make available through the cloud edge continuum to those AI workloads that are going to be deployed by European SMEs and other companies in the near future, or are already being used by a number of companies in Europe. And that's something I would like to follow up with you guys. So that's actually the next question. So how are you, from your perspective as application providers, how do you, or platforms, how are you actually using artificial intelligence now, or expecting to use artificial intelligence in the near future that might require specific capabilities from this cloud edge continuum? Who wants to start? Cybersecurity, maybe?
Yeah, of course. So I don't necessarily master the subject, but yeah, what can I say is that in field of cybersecurity, artificial intelligence play a crucial role. For example, In the use case, we use machine learning technique to detect abnormal behaviors that may indicate intrusion or attacks. And it enables us to automate real-time threat response, predict future threats through predictive analysis, and proactively strengthen our defense system. So yes, AI is of course important and play a role, of course.
Francesco, what about you? Because I know you guys are doing very interesting stuff.
In our field, in particular the environmental analysis in research, one of the main challenges is to try to foresee the behavior of a complex system from forest to oceans. And this is one of the main way we are trying to apply artificial intelligence. From the data we are collecting from our devices, sparse, we are trying to extrapolate the behavior of the entire system. Also because, of course, monitoring each single individual in all the turtles in the sea, all the trees in the forest is not possible. So using artificial intelligence for big computing and for foreseeing possible scenarios is one of the main use. Other ways we are using it is for example, reconstruct forests from LiDAR. We are using lasers to reconstruct the volume of the trees to calculate the carbon that has been collected by the trees, because also carbon will become probably a very important asset in the future. Europe is moving in that direction, and so we are finding ways to calculate the real carbon that has been stored, and one is the LiDAR, and we use artificial intelligence to reconstruct the volumes and calculate it precisely. In COGNIT, we are using it for image recognition, and in particular for confirm the presence of fire after the sensor indicates a possible fire that is spreading. Thank you.
Okay, thank you.
So I would say that in our case, we have kind of like two dimensions where we need artificial intelligence. Nice cut, Alberto. So
it's always in some of in every conference, Open Nebula conference is there at some point. So this is the one. This is the session where she actually.
I'm wondering if he's doing some of the coding.
No, I hope no.
Your co-pilot.
I once heard that Perl scripts, they are just written by kittens walking around the keyboard.
This is my cat pilot.
Okay, but back to AI. So, two dimensions of the AI that we are needing. So the first one is when we are talking about what is lacking, we need the resources to be available to the edge devices. So to make them available, we need AI to have to perform smart decisions of when and which nodes should be available to each device when. So this is very, very useful, and this is what we are doing in COGNIT and researching these aspects. And then the other dimension is functional dimension for the use case for the device itself. So if the device is not rich in resources, and it would be very good idea to have functionality that is based on the ML or AI. We would like to perform some recalculations based on AI model on those resources that are available to us because another AI prepared that. So yeah, functionally wise, in energy use case, we are using AI to predict what will be the production and consumption of each user, and based on those predictions, we can manage household devices to make them work when the energy is cheaper. So when we know it's going to be produced, we can turn something on because we know we will be using our own energy produced in our household. And for that, we are using AI models that are available to the device in the resources prepared by COGNIT framework. We do direct calculations on those resources which are close to the device, so we have it available fast. And then for retraining, we don't really care if it's done close or far away, so it can go to the cloud and the model can be retrained there. So this is exactly what we are doing in COGNIT, what we are researching in COGNIT now. And well, I think this is going to be the future for every sector, because in every use case, in every scenario, we'll find the place when we are reaching the limits of deterministic algorithms and we want something more. And then, well, the next step is to reach to ML AI and use that.
Yeah, but as you said, not the same. Not always the same resources are involved in the different life cycle of these models, right? So training can happen at some point, and the actual use of the deployment of the model at some point for some specific data comes from. I mean, has to be maybe closer to the device, right? So.
Yeah, we need this dynamic resource availability. So we need a lot of flexibility, as Torsten said. This is the main requirement now, that it has to be available fast and it has to be what we need. For some cases, we can wait, but then it is a matter of smartly using AI to figure out fast if this device, if this client can wait or cannot wait, what is available nearby to perform calculations and have low latency, for example. And that's it.
Okay. Torsten, what do you think? I mean, how you guys are using AI?
Yeah, so for us, so for us, it's as we are not an application developer in that kind of, right. We are, as I said, we are looking into the infrastructures, but even there you have you have sometimes the challenges to place something in the right area, or for instance, what's also some kind of challenge where we try to help our customers is, I mean, if you operate infrastructures in the edge, I mean, then you're not talking about dozens of systems. You're typically in the thousands to 10,000s to 100,000s of systems, right? And that's exactly where the scaling comes in. I mean, I'm sometimes very straightforward saying, well, look, what is artificial intelligence, right? If you were very simplistic, you can say it's kind of big data 4.0, right? And there it comes in. If you, for instance, you have these vast amount of devices that you run in your edge infrastructure, and by just the number of that, you will have some devices that will have some problems. And to identify that, and I see what also Malik were telling, to identify the anomalies in that kind, to find and very straightforward fix items that helps our customers. So there I see developments going on. I could also imagine, for instance, as we were also talking about, that it's about bringing the two parties together, right? The sensor and let's say the heavier number crunching. I could also imagine that instead of let's say storage solutions that we have, where we would like to know, okay, where is the prediction, where it is needed much more quicker than in the rest of the nodes to replicate data, right? I could also imagine that there we will follow more on artificial intelligence opportunities, which we don't do right now, but that's something that I could imagine going forward.
Yeah, in our case, Alberto, for traffic management, it is like quite a key tool now, because traffic planification is based on forecast. So you need the traffic forecast in order to planify the whole city or even a motorway infrastructure. So in the past, these forecasts can be done by interviews or just by counting by hand the cars, how you take the OD matrices to know where the cars are going from where to go to where. But right now, before the artificial intelligence, some other tools like Kalman filters were used, because this is quite a valuable data to have. But these Kalman filters were used for forecasts, for fill up missing data. But these are quite tricky to tune up. It's a tricky algorithm to tune up. And right now, with the artificial intelligence, what we see is that is more achievable, more easy to get in and to start to get forecasts and to get this value for traffic management. Yeah. And of course, later, one of the topic of the year, that is large language model. We are also analyzing how to integrate that in our platform, mostly as an interface with end users or with traffic operators, in order to get value from the data they have. Because in our sector there is a lot of data that has not been traditionally exploited, and now with these tools that are easy to tune up, we foresee a future with more applications related to artificial intelligence. Yeah, sure.
Okay, great. Yeah, we have less than 10 minutes, but I would like to use this opportunity that you are all here to ask you if we could create like a small wish list. So from the application perspective, if you think about, COGNIT is creating a serverless framework that's using this underlying cloud edge infrastructure and building this abstraction to the applications for them to be able to upload code to the Continuum and execute some tasks that are too heavy for the devices. But I would like to ask you more generally, as application providers, on the basis of your current use cases, the use cases in which you are involved in the COGNIT project, but also your broader experience in the cloud market. What do you really need? So what will you expect from this European cloud edge? After you experience, I'm sure most of you with hyperscalers platforms, if there was when there is finally a European edge cloud offering, what do you think are the main requirements that, from the application developer perspective, have to be met by that platform? Again, coming from your experience with COGNIT, but also broader experience in the cloud. Who wants to start?
Well, let me take it from the SUSE perspective, because this is, I guess, the most generic one.
Exactly.
So what we've seen, because we are not developing specific applications, but anyway, if we are talking about our infrastructures, especially in the container area, we always see these discussions around the developer should not need to spend a lot of time on thinking about the infrastructure, right? It must be very straightforward. It must be very simple to address. As we invest in the COGNIT project also, and I mean, we had iterations in the meetings where we found, okay, we need to make this less dependent on information and to instruct from the developer perspective that he needs to ask for specific things and to go to specific areas. It's just, hey, I need this, and the rest must be done automatically. It's always a bad thing if it gets too complicated for the development, right? And I guess this abstraction is a very key thing for anything that you provide as infrastructure or as management of infrastructure to developers.
Yes, I totally agree with that. If I make, as I mentioned before, what we see, what our developers are suffering is that they are of course they know the cloud solutions and they are familiar with cloud solutions and developments, but when they came to ACISA, they face the reality of working against real infrastructure, no? And it's difficult for them to understand how things can be so easy in the cloud and how things are so hard you have to face with switches and routers and the proper servers, no? And yes, what our wish list is that for us should be that to develop in this private cloud and edge infrastructure should be as easy as to develop something in the public cloud, no? This should be our main wish list.
Yeah, and also this is also one of those aspects. Also, what infrastructure is behind. So if it's in a public cloud environment, if it's on-prem, if it's something that you have in branches, you run on your own, the kind of how you interact must always be the same, right? So no matter where it is, and this is also one kind of the abstraction that it requires.
In my opinion, it's also important to make people understand the use and how can it be of use to them, because of course developing and using this technology requires work, and I think it will always be required. Also, if simplified, you need, because people found a solution probably to assess their problem, to respond to their problem. For example, at the moment with the centralized cloud, the important thing is to make people understand the value of this technology in a way that they are they willingly want to deploy that and put time and resources to use this technology. If instead we speak about wish list, I would like to be able to integrate pay-to-use platform, my own resources and other things to and minimize the use to pay-to-use platform when I really need that. So be able to use all the resources available to the organization, but also external, managing to leverage the cost only when I really need them, if we speak about wish list.
I completely agree with all of you guys. On top of that, I would add just that, yeah, it has to be easy, but don't kid yourself. Nothing ever happens by itself. You always have to put some work, but we have to make this work easier for the developers. So we need some tools. We need some easy to follow manuals and samples, examples of use. And that this is when the platform is easier to use and accessible to the programmers.
Yes, I would also add that in our case, at least, that we, as traffic maintainers, traffic infrastructure maintainers, that is considered a critical infrastructure. So not to say that the top priority is security for sure, and then it gains all the rest. So not to mention that security is for sure that should be in the top list, but then came all the rest. Yes.
Okay, that was a nice wish list. I think we'll have written down everything. So No promises, but no. I mean, as you know, the as part of the COGNIT project, it's a research project, and as you know, we are addressing some of these requirements. But it's also always good, also as part of other projects that we have at European level to make sure that whatever the European industry is doing in terms of building this cloud edge continuum, it actually responds to the needs of the application developers. Because in the end, you guys have to be able to sometimes even encourage or work on your own colleagues to sell the benefits of moving away from some of the platforms they are already using, that they're familiar with, and move away from that to this new continuum we're building. So from a technical perspective, it's also the user experience. Things have to be as easy as possible to make that transition. Yeah. Okay, so I think we can call it a day. Thank you everyone for joining this panel, and you had I think it was a nice conversation. As you know, we'll have another round next year, just to see how the different use cases are progressing in the next Open Nebula conference and in other events as part of the COGNIT project. But yeah, so we'll keep working on the use cases and the project, and I'll see you guys in the next consortium meeting actually. So thank you everyone.
Thank you very much.
Bye bye.
Bye bye.